Hi everybody, this is Ken from Machine Safety Specialist, and today we are here to talk about our new enhanced three-state risk assessment spreadsheet. We'll just kind of give you an overview first and then we'll dig into an example. As we look at the tabs across the bottom, you notice there's a flowchart that shows the risk assessment process, and that is combined with a hierarchy of controls. If you don't know what those are, we suggest you take our machine safety and risk assessment training course, and you can find more information about that on our website. The next tab shows a list of tasks. If you populate those here, and you can, by the way, you can make the list smaller or larger, then they show up in drop-down menus later. Also, the list of hazards. This is a list of drop-down hazards that are populated with hazards found in ANSI B11.0. Again, if you don't know what that is, we recommend that you take our class on machine safeguarding and risk assessment. The next tab is the main tab that we'll focus on. This is the risk assessment tab. And then for reference, we have additional information. These are tables that we'll reference, and these show the severity of injury definitions, exposure, and probability avoidance risk factors. All those are shown here with a definition as found in RIA 15.306. That's a very handy and useful risk assessment method. It works very well for all machines and also robotics. And then over here on the right side, the next table that we refer to is the logic table that shows how the risk factors equate to a certain risk level. And then table 4 is our guidance for letting us know what type of risk reduction measures need to be applied depending on the unguarded risk level. The next tab is a handy table out of ANSI B11.0, and it shows which risk factors change depending on the risk reduction method as applied. For example, if you add separation, you're lowering the exposure, but not the severity, and so on. That's a handy reference. Without further ado, let's dig into how to do a risk assessment using this tool. And you'll find out that you're following the standards, specifically ANSI B11.0 and ANSI RIA TR 15.306. The first thing you do is identify the machine and the scope of work under the risk assessment. You identify the date, and then very importantly, you identify team members who are involved in the risk assessment. This should represent a multidisciplinary team. So you've got input from maintenance and engineering, also a safety professional, and production involved, and as well as others may be involved. And that's where their names and their roles and titles get listed up there. Then we drop down to the first task. Now, all the standards require a task-based risk assessment, and that's what we're doing here. So a task is a human interaction with a machine. So the first task may be load part, okay? And steps further, that task may be reach into fixture, load part, and specifically clamp part, and then start machine in our example here. Now, potential hazards, what could go wrong if the machine accidentally starts up or a second person clamps while the first person is reaching in? In this particular machine, we're looking at pinch points. So pinch points are the hazard we're analyzing. And now we will get into this a little bit more, where you will see the beauty of the three-state risk assessment. There are always three states when assessing risk. The machine without any safeguarding, that is a theoretical, imaginary state, but it needs to be done for the standards. So that's the unguarded machine. The next state would be the existing safeguarding. That's how the machine is now. And the next state is the future risk reduction measures. It's what you want to do. And then finally, the future risk estimate is after you do these future improvements to the machine. Let's go back to the risk assessment without safeguarding, and we'll zero in on this and start working on estimating the risk factors. Okay, so when a person reaches in and loads the part in the machine, they could be subject to a pinch point. That pinch point, we'll estimate that as an S2. That means it's a reversible injury, but they do it very frequently, so more than once an hour is an E2. And the probability of avoidance, let's say the clamps move really fast and it's unlikely to get out of the way, we would score that A2. Now you may wonder, hey, how did you come up with S2, E2, A2? Well, we'll describe that to you. That is over here in the tab that describes the definitions for the risk factors. And here's a definition for severity of injury, exposure, and probability of avoidance. We see that the injury severity S1, S2, S3, that is the expected outcome if you reach into the machine and you make contact with a hazard. And exposure would be low or high. E0 is a very special risk factor, and you can only score that when all the criteria are met. Warning, do not score E0 unless you know what you're doing, unless you've had some further training and risk assessment. Probability of avoidance is either not possible, not likely, or likely, and that a lot of that depends on the speed of the machine and several other factors defined here. So let's go back to the assessment, and we see we scored that S2, E2, A2. It's telling you that the risk level is high for this operation. Of course it would be with it being unguarded. It's asking you if a control circuit is required. Here we're going to say yes. We're going to use a light curtain, for example, to mitigate against this. Control circuit required, yes. We see that the circuit, based on this unguarded risk level, the spreadsheet has a lookup table, and it's telling us that the circuit needs to be at least category 3, performance level D. To put that in old-fashioned ANSI terms, that means control reliable. We need a control reliable system that's at least Cat 3 PLD. Now we switch over to the state that is the existing safeguarding. So with the existing safeguarding, again, we mentioned that this is guarded by a light curtain. It's asking us what method of controls. Well, a light curtain is considered safeguarding. And administrative controls, let's assume that we have safe work procedures in place. And let's just describe that. Machine has partial guarding, a small light curtain, and work procedures are posted. See photo 1. All right, partial guarding, small light curtain, work procedures. Now, with this in place, then we're going to rescore this. Still, severity of injury 2. The amount of exposure may be a little bit lower with that in place. And our probability of avoidance, likely A1. Now, with the machine guarding in place, even though it's not perfect, we see that the risk is medium. And this shows the middle state here, which is the existing state. Now let's talk about the future state. We want to apply in the future better safeguarding, better administrative controls, and so on. So let's just say guarding comply with the new version of ANSI B11.19. By the way, if you don't know about that, I would check our website because we will be offering online training on these new safeguarding standards, the latest versions. So we want to make the guarding comply with ANSI B11.19. Ensure light curtain and stopping functions also comply with ANSI B11.19 and ensure safe work procedures are in place. Okay, remember that we're describing what our future safeguarding is like. When that's done, who do we want to assign this to? Well, let's just assign it to Ken, and let's ensure that he completes this later this year in the middle of the summer. And when all this future safeguarding is in place, we are going to estimate the future risk when all those are done, and that would be probably an S2. And when we do all these things, we may have achieved an E0, and again, be very careful about doing that. And our probability of avoidance is very high, therefore we score that an A1. And our overall risk level, after we do those risk reduction measures described here in this cell, then our residual risk level would be low. However, note that E0 may not be scored until the actual system is tested. That's a note in the standard. So good intentions are not good enough. So I'm going to remove that. And when the machine is actually upgraded, I'll go out and measure the machine. We'll check that we have a full compliance by doing a machine safety inspection. Make sure that we will comply with OSHA and ANSI and NFPA standards. And if that fully complies, then I'll come back and score this E0, but I'm not going to do that until I've done a very thorough machine safety inspection or until I hire a third party to do that. All right, so that completes this row, and I think you see how we step through this risk assessment. Now you keep on doing this for every human interaction in the machine, and you want to do this in normal operation, also in minor servicing and in maintenance modes. You may also want to include a commissioning mode on that. You may end up with dozens of human interactions that are listed here under tasks. And you will see that now these are described in the spreadsheet in 3 states. And those 3 states are unguarded, it's a theoretical state, and then existing safeguarding, that's how it is now, and with future safeguarding that you may want to recommend. I hope you've enjoyed this tutorial on our 3-state risk assessment spreadsheet. We wish you all the best, and we ask that you would please work safely.